Hey YouTubers, today on the workbench I have this Peavey MegaBass solid state biampable bass guitar amplifier head. Customer's main complaint is it's not functioning in biamp mode, but after we got into it we've discovered several other little problems that we fixed, so let's get to it, okay? So there's a modest amount of dirt on the cover here and some on the circuit board. Not a big deal for an amp this old. Don't know the history of it, if it's ever been serviced. But there's something interesting here. It's a wasp nest sitting on the board, probably shorting out the circuit. Referencing the schematic diagram, we do see indeed it is shorting out across the positive and negative 15-volt power supply. Okay, to remove the front panel, we're going to label the connectors, disassemble it all so we can clean all the potentiometers, the switches, and we did note some EQ faders that were extremely bad. Alright, we are going to completely remove the silkscreen front panel from the circuit board so that we can clean it thoroughly. As you see, I've got the knobs removed. It's ready to come out, but first I have to remove the LED indicator and unsolder it and the power switch from the panel just to make it easier to work on and a lot easier just to clean that front panel. And we are making note of the positive red and black negative that go to the LED here on the board. Okay, front panel is out. What you have here is sandwiched circuit boards, the chorus board top, preamp board's in the middle, and the EQ board is on top of that. So next we just have to remove all the hardware, the screws, the nuts, input output jacks, and we'll be ready to take this panel out. Okay, hardware is removed, ready to remove the front panel from the circuit board. Panel comes right off. Now all we have to do is remove the chorus board and the EQ board from the main board here, and there the two are separated. After removing 4 screws that holds the EQ board to the preamp board, it'll just lift right off. Okay, after removing the EQ board, making note of what position it was placed in. When looking at the pin sockets and the pins, they all look in real good shape, nothing bent. Pins look nice and shiny, with no corrosion whatsoever. Alright, we have all the screws removed. Now the chorus board unplugs from the preamp board. You'll notice that there's 3 or 4 sets of male pins on this board and the female sockets are on the other board. I'm going to give it a quick visual inspection, looking for broken solder connections, heated parts of the circuit board, stuff like that. We'll look at it in a minute with the magnifying light as well. I like to use this deox cleaner. We're going to spray it on all the potentiometers and the switches. Rotate the potentiometers back and forth a few times and the switches, click them in and out. And we'll repeat the process about 3 times on each of the components to make sure they're clean and lubricated. Next, we're going to remove the crossover board and clean the stacked potentiometer on it. So I just cleaned it real quick off camera. Now we're going to examine this power supply board. One capacitor looks overheated and or leaking. These are filter capacitors for the low voltage 16-volt power supply in the amplifier circuit. Turning it over to the solder side, you see that it looks like they heated up pretty good. Rosin flux is coming out from the solder joint. There is a lot of solder on all these nodes. Capacitors, those are the high voltage ones there. But I don't think Peavey would have let this go out of the factory without cleaning that flux off the board, so I think it's heat. And since there's so much solder on these capacitor nodes, I decided to use this desoldering wick instead of the vacuum or the solder sucker tool. Okay, I sped the video up about 4 times, but you know, this desoldering process is about exciting as watching paint dry. Okay, after most of the solder is removed, I went in with my little wedge tool and trying to bend up the capacitor leads. I'm going to clip them all off flush once I get them straight up, and the cap should pop right out after that. There didn't appear to be any epoxy or any other type of glue holding the caps to the circuit board, but we will find out. All the solder's off. We'll clip off the leads and pop that one out. This one's being difficult. Got to take some more solder off. Okay, we got the caps out. Now we're just going to clean the circuit board up with some acetone. Get ready to put the new parts in. Alright, I soldered the new capacitors in and forgot to hit the record button. As it happens, new 63 volt 1000 microfarad capacitors for the 16 volt positive and negative voltage of this amplifier. Now we're going to get on to rebuilding the equalizer board. Two of these faders needed some serious attention. The 63 hertz fader was not functioning at all, and the 160 hertz fader was cutting out. So they both got rebuilt. The spring tension of the wiper has failed. So that loss of spring pressure has caused a dropout in the continuity between the wiper and the carbon element. Both faders for 63 and 160 hertz had been disassembled and rebuilt. Now some more very exciting desoldering. Okay, there's 5 solder points on each one of these faders. 2 of them are merely anchor points, no electrical connection there, and 3 others that are the actual circuit connections that have to be desoldered. Okay, here I'm just brushing on a little flux to help heat up the solder for removal. Now we're using the soldering pencil as opposed to the iron because the connections are much smaller. And again, I chose to use the desoldering wick. Again, you're watching the video in 4 times speed. Okay, finally got all the nodes desoldered. Now we're just going to flip it over. Take a little screwdriver and pry up underneath there and pop them up. Sorry, the video's out of frame a little bit. And there it is, ready to be disassembled. Okay, to take this apart, we have about 8 metal tabs to bend up straight. Then we can pull the thing apart and clean the carbon circuit board and attend to the repair of the wipers. Carefully bending the little tabs straight. Once we get them ready to pull apart, be careful. Some of these have ball bearings and little springs in them that hold the contacts. But as we took this one apart, we didn't find any of that. We just found the little wipers on both sides. We will clean the carbon surface with denatured alcohol in just a second. 2 contacts on the left are the common. The 3 on the right are the resistive. They need to be cleaned and bent to have more pressure. Being very careful, they are delicate. Bend them up slightly. Be gentle. You don't want to break these. These parts are no longer available and very hard, if not impossible, to find a replacement. Alright, once again off camera, I cleaned the carbon strip with some denatured alcohol, and now we're just putting it back together. Carefully crimping the tabs back over. Don't want to crush them too far, so I opened up the pliers to a reasonable setting so I couldn't over crush the crimp, you know. And that's all I'm doing here is putting it back together. So look at that, all back together, good as new, one would hope. Now it's time to bench test it, the resistance. It's a 20K fader. Should be 10K in the center where it does have a detent where it locks in place. It goes from 0 to about 11.6, which is acceptable. Now we can go slowly and see if there's any dropouts. Notice there was a little glitch right there. Shouldn't be too big of a problem. Should work fine. Going all the way down to 0. Looks nice and smooth. These are what you call linear taper potentiometers. Tone circuits use linear most of the time. volume uses audio taper. Okay, so let's get ready to put it back in. I think this is good to go. Now the slider lever does feel firmer, much tighter. So I think we got it. Okay, let's put the fader back in the circuit board. It'll only go in one direction. Line up the pins and pop it in. Get ready for the solder. We will solder the anchor points first and make sure that the fader is completely seated on the board before we proceed to the other three electrical contacts. Okay, after I put it back in the circuit board and float some solder on the anchor point, if I turn it over in a minute, you'll see that it's still stuck up a little bit above flush from the other ones. See that? We'll heat up that anchor point and press, and there it goes, lays flat. We want to do that to both anchor points before we solder the other three electrical connections. Okay, here I'm just soldering the rest of the connectors. And once I'm done soldering these, I'll clean the board up again with some acetone with a Q-tip, checking it with the mag light to make sure no solder, bridged any nodes. Don't want any of that happening. Don't want no short circuits. It's a lot of work to take this thing apart, so you don't have to go back because you mess something up. And here I'm just cleaning up the circuit board with the Q-tip. Sorry, it's not centered again. Checking my work. Looks good. Look at that, nice and flat. Okay, one more time. I'm going to spray Deox in there. It does have some lubrication. I don't know, I'll just pat dry it, let it dry off, and plug it back in the board. Okay, now we're ready to put the EQ board back to the preamp board. Put the 4 screws in it. Then the next thing we'll do is put the chorus board back on top of the preamp board. It had like 8 screws. I went from the center out, torque coming down slowly. And also checked the IC chips to make sure they were fully seated. I did press down on every IC chip that there was to make sure they were seated fully. It is a good idea for the designer to put sockets there in case a technician later needs to replace an op amp or two. Time to assemble the front panel to that circuit board. So what I did, I laid the front panel down and then put the preamp board on top of it, and then just put the nuts for the input jacks to hold the panel in place. Then I can flip the panel over and do all the rest of the fasteners. Here I am just putting all the nuts on the potentiometers. This next part is out of sequence in the video, but I did want to show I pulled the control board out because we're going to clean the heat sinks. A dead spider in there, not surprising. Now under here is the power amp board. There's 2 amps A and B. One's for low and one's for high range in biamp mode. And the heat sinks are under there, and I'm sure we're going to have some dirt to clean up. You have your inputs and outputs on these modular pin sockets, and all these push-on spade connectors are for power on the bottom of the screen. Here I'm just showing there's 8 mounting screws that hold the whole heatsink power board assembly to the bottom. There's a thermal switch for the high-speed fan. And we're ready to pull this board up so we can do some cleaning. So you see, not too bad for an amp this old though. There's a view of the heat sinks with the power transistors mounted. Alright, everything was cleaned. Solder connections were double checked. Everything looks good. Put the whole assembly back in place. Screwed it back down. All the power connectors are plugged back in. Checking the pins here. Ready to push it back together. Alright, putting the main control board back on the power amp assembly. We're just examining the male pins as they stick through the connectors and making sure that every one of them came through as they're supposed to. You can see the male pins coming through the female connectors. Alright, now the control board's back in place. We're going back to the power supply. These are the two 4K 5-watt resistors that need to be changed. Those resistors do look like they're stressed out, overheated, disintegrating a bit. Some of the white ceramic or sandstone, if you will, is coming off. You can see it laying there on the circuit board. Let's get them out and take a closer look. So I'm going to clip these leads on the top here and give me a little bit of a nub just to push through the circuit board. That'll make them a heck of a lot easier to change out than those capacitors were. And here's the tedious process of desoldering these leads. You see, I didn't use any wick. I just heated them up and pushed them through to where I could bend them up and grab them with the pliers and then pull them to the circuit board. And later I cleaned up the circuit board and installed two new 4K 5-watt power resistors. Here's a picture of one of them that crumbled with a very light pressure of the pliers. Alright, now I'm just double checking all my connections, inspecting the work. Going to go back here and look at the back panel because we haven't looked at it yet. And lo and behold, we see another problem. The cooling fan normally operates in slow speed as the power goes through both 159 and 160 resistors. When the temperature gets too hot, thermal cutoff switch TB1 closes, therefore bypassing the 1K resistor, allowing more current to go to the fan. If the 1K resistor R160 were to burn open, the fan would remain off until TB1, the thermal breaker, reached temperature and allowed the fan to turn on by completing the circuit. If R159 had been burnt open, the fan would not operate at all. It's hard to see at this angle, but there is a crack in the ceramic on the one resistor. Replacing them both is considered preventative maintenance. As you see, I marked the board where all the connectors plugged in. Got the board out and ready to unsolder the resistors and replace them with the new ones. All the other components look to be in good shape on this board, but I will be testing them with the ohmmeter to see how close they are in spec. Just by observing these resistors, you can see that the ceramic is coming out of the block, and one is darker color than the other. That would be the one that dropped most of the voltage when it is in slow speed. I decided not to record the desoldering of these resistors, but as I was handling this one where the crack was, it fell apart. Because the fan will draw maximum current in high speed, I opted to put a 10-watt 500 ohm resistor in its place. Okay, two new resistors are installed. The black one obviously is the 10-watt 500 ohm. That will be the only resistance in the circuit when the fan is running on high speed. So I thought it was a good idea to upgrade that wattage. So let's take a look at the component that part of the circuit runs, and that would be the cooling fan. Took the blades off just to clean everything, and inside we put some oil, put it all back together, and heck, while we're at it, we went ahead and spray painted the grill for the fan. Now let's go back to the front of the amp and install the front panel and plug everything back in. Although most of these connectors laid back right where they were supposed to be plugged in to begin with, labeling them with a fine tip Sharpie marker did make it easier to assemble quickly. Everything is a very tight fit in this Peavey amp. Okay, we're getting real close to testing time. Okay, here's what we got for our testing setup. We're using these 2 wedge monitors, 12-inch woofers, and a horn. I won't be playing any bass guitar through them. I will be using pink noise provided by this old equalizer with a built-in spectrum analyzer. And I have this old Night Labs piece of equipment for a signal generator at this time. Got that back in tech school. One output's going to the Peavey, the other one's going to this frequency counter and this oscilloscope. Very old pieces of equipment, but hey, they still work, so we use them. Okay, first we're going to start off with pink noise generator. It's in full range mode. Punch switch out and the pad is off. Chorus is off. Input pad, it works. Punch works. Brightness definitely works. Chorus hard to hear. Alright, let's go through the frequency bands. Yep, that's working. 160. Yep. 400. 1000. 2.5K. 6.3K. And 12K. It's hard to hear, but it's working. Okay, next we're going to do the same thing basically in biamp mode. So first let's turn the volume back up. Switch it to biamp mode. You hear the volume change. Right now I sit midway at about 800 cycle crossover point. There's the high end, which is this one on the right. The low end over there on the left. And watch when we sweep the crossover. Okay, you hear them both go low. Now this is 1.4K, goes all the way up to 2,000. So at 2,000, you hear the hiss out of the right channel and what's going on in the left channel. So now let's just listen to the left channel low. It's all the way to 2K. Sweeping it back, you can hear it cutting the high frequencies, just like that. We'll do the same thing with the high output. You can hear all the hiss, sweeping it. You hear the lows coming back in. Okay. I think it's probably should be crossover right about there, but that's just me. Okay. So here again, in biamp mode, let's check the pad. Works. Check the punch. It works. Check the brightness. Definitely works. Switch it back to full range. Okay. I say that's a win. Okay, running the sweep tone generator. We have roughly 67 cycles. Right now we are in biamp mode again. So you can hear that hardly nothing of that's coming through the high end, crossed over at 400. There's your low frequency. Pad's working. Punch, definitely working. 63 cycles, working wonderful. A little scratchy in the 160 as we thought it would be. Okay. Bright works. The biamp mode draws all the power of the low end to the one side, more so than the other side. Still there though. Okay, I'm going to go to next frequency. We got about 133 cycles. Pad, punch, 400. Hardly no difference on that signal. 266. And let's do the same thing. Input works, punch is working, bright's working. It's in biamp mode. We'll sweep it again just so you can hear it. Oh, it's in full range, sorry. Biamp mode. Doing what it's supposed to. Now we should be able to hear the chorus. Now, the chorus is only on the high output in biamp mode. Demonstrate that by putting it back in full range. Now we have it. As you can see, no chorus on the low range master. It's all on the high range. Okay. I'm going to go up again. About 530 cycles. We'll turn the chorus off. We know it works. We're in full range. Let's check everything. Pad, punch, bright. Go to biamp. You hit there's your 500. See right there, you can tell it's right starting to affect it. And the low range. Alright. There's about 1,000 cycles. I don't know if we have to go any higher than that with this. We're still in biamp mode. And you hear it's still coming through the low range a little bit. See how it cuts out completely 1,000. That's where it gets louder because that's the crossover point. Thousand cycles. Pad. Punch is ineffective. Bright is very noticeable. And you hear the chorus working. And full range. Okay. And we'll just do one last test doing the sweep generator, which just goes through all of its preset tones. And now a quick demonstration with clean guitar and the chorus on. It really shows how beautiful this chorus does work. And for copyright purposes, I'll only play a few seconds of it, but this is the Rain Song intro from Led Zeppelin.